Rules of flow in construction, time buffers. I love this topic because we should be using time buffers for everything that we do in construction. If you're not using time buffers in your project, then you're probably suffering. Every production plan in the world, let alone and actually the universe, should have time buffers because you will always have variability, you will always have delays, you will always have impacts. So let's talk right now about how we can literally create a critical chain instead of a critical path by adding buffers to the system. This is a super cool topic. Let me talk about this right now, time buffers. Let me start out, when you're doing a production plan, I always do it in a time by location format. You probably know that about me by now. But if you have your production plan in a macro level TAC plan format or a norm level TAC plan format, however you do it, you have your overall sequence, right? With your lines of balance, with your buffers, and it's all tied together with what's called interdependence ties throughout the project. So you will have what we call intact, and it's called a path of critical flow. This path of critical flow will go all the way to the end. There is another name for this, and this is called a critical chain. What is the difference between a path of critical flow or a critical chain and a critical path? First of all, we on this YouTube channel do not believe in critical paths because they don't have buffers. They don't have schedule contingency. You must have buffers at the end of your overall production plan. And here's how it's put together. When you're looking at a TAC plan, you have a sequence, you have in the diagonal your line of balance, and you have your logic tie, and you have your buffer. A critical path will only have the activity, the sequence, and the logic. It will not have a line of balance, and it will not have a buffer. And those are two things that you need always to flow wherever you are, okay? And so let me tell you this. This buffer here is to absorb any delays and variation. Most of the time, all or most, we recommend at least 75%, 50 to 75% of your buffers. If you're gonna put buffers here or here or here, we actually recommend those coming in at the end, right? Putting them at the end. Now, here's the key concept for you that I hope you get. There's something called Parkinson's Law. And what Parkinson's Law is that the work or the time to complete work will extend to fit the time allocated, right? So the buffers being at the end also allows us to have a really nice target right here for people to target so it doesn't artificially extend, but we also have buffers in case we want to keep that trade flow and move the project and cascade the activities in case we have a delay or an impact or something like that. So this is key. Now let me say this, you'll also have supply chains. So you will have a supply chain that feeds this. This is called a resource buffer, and what that means is that if you have a supply chain, you must have a buffer at the end of the supply chain before you feed it. The other thing that I would say is, let's say that there's a timeline, something else that feeds into your path of critical flow, you must have the buffer on the end of that. That's called a feeding buffer. So feeding buffer, resource buffer, and then you'll have the actual project buffers. We call this a calculated end buffer, and this is mainly to absorb the risks of the actual construction project. So there's a couple of purposes for these buffers. Number one, this buffer protects the overall project from extending past the owner's substantial completion date. The resource buffer makes sure that the supply chain doesn't affect the path of critical flow or the critical chain. And your feeding buffer, other timelines, make sure that the same thing doesn't happen, meaning that it won't negatively impact the path of critical flow or your critical chain on your construction project. The bottom line here is this, and everybody must know this. Yes, we want to plan projects to where there's as little variation and as little impacts and as few delays as possible, but that is not going to always remove all of them. If you're in construction, you will have delays, you will have impacts, you will have variation. There's a difference between the types of variation, let me say foreseeable variation and impacts and delays, and non-foreseeable or unforeseeable variation, impacts and delays, right? So this is something like acts of God, weather, that isn't a historical pattern, right? Or let's say something happened in the government, or a war breaks out, or something happens, like some force majeure type thing, or it could even be as simple as an owner or a design change, right? This is non-foreseeable variation, delays, and impacts, right? Foreseeable would be risks that we commonly encounter, weather that we know is going to happen, possible delays that we've experienced before, right? These types of things better be covered in the buffer, and we need to protect against it, right? So a buffer in construction is kind of like an allowance in cost accounting from a construction standpoint. It's specifically allocated to buffer a specific risk. So we do need to make sure that we have a risk analysis here. But let me just say this, buffers are a thing. They're a part of having flow. Now let me just draw a couple of analogies right here. Now let's say you don't have a buffer on a freeway, no space between the cars, no extra capacity. Does it go faster or slower? Let me talk about your blood pressure. If you have high blood pressure, no buffers, right? It's just packed in there. Does your blood flow better? Or does it flow worse? It flows worse. In fact, sometimes they won't even do injections or IVs or blood draws because you don't have ideal blood flow. Flow comes from having buffers. You must have that buffer, that space, additional capacity for ideal flow. There's analogies abounding everywhere. The concept here is that we want to plan for uncertainty. Let me just go ahead and write this down. So a risk, a delay, an impact, and variation, anything that like changes the plan, okay? We want to protect ourselves, right? And plan for uncertainty by having these buffers, not by planning on being James Bond in the moment. I said in another video, and I'll say here again, I love the movie Equalizer. I love the Mission Impossible movies. I never got a chance to really watch James Bond, but like a lot of these videos, you know, where you see Denzel Washington and like his eyes like looking around in like a matter of milliseconds. He already knows how he's gonna stab this guy in the eye and hit this light switch and do the, and all that. That doesn't happen. We don't account for uncertainty with improvisation and planning on being Denzel Washington in the moment. We plan on it with buffers, okay? Now this does not release us from our need to properly plan. So let me just remind us, when you have a phase in construction, if you remember, always do a pull plan 3 months ahead. Always do the pre-con meeting 3 weeks ahead. Always do look ahead planning 6 weeks out. Always do weekly work planning a week out, and always align the supply chain, right? These are habits of a builder. And if you do that, you'll reduce most, if not all, of the foreseeable variation, delays, and impacts, but not the unforeseeable ones. And so let me close out by, well, let me ask you to like this video. This is all attributed to the Goldrat family and Goldrat's Rules of Flow. Absolutely love their work. It's all centered on one piece flow, one process flow. But let me tell you the philosophy here. The philosophy here is that we don't want unnecessary like sandbagging or additional safety factors put into the activities themselves. If we have a buffer, we want it at the end. If we have a buffer here or anywhere throughout, we must also have the buffer in the other timelines and in the supply chain as well. And buffers allow us some flexibility to maintain flow, because flow is not, ooh, this is so good. This, oh my gosh, this is so good. Flow is not lost when there's an impact or a delay. Flow is lost with our reaction to the impact or the delay. Meaning if we start to stack or burden work, that's when we enter into a downward productivity spiral, and that's when we get in trouble. So it's not the delay or the impact that's going to mess up our project, it's our reaction to it. And if we follow this methodology with buffers, because in the TAC production system, we're able to rezone, we're able to design to the work package, we're able to narrow durations without hurting trade partners, we will be set. So it is a lean concept to add buffers, even though we're targeting here, which is going to challenge the team to perform with a strenuous performance goal. I really hope you've liked this. This is so important. I'm going to put it into a Canva graphic and a blog post and link you to the Goldrat's Rules of Flow book. But I hope you've loved this, that you can implement it. And just remember, always have buffers. On we go.